Okay, Math Nines, we are doing our final lesson of our exponents unit. There is an extension 2.6, which is a Math 10 lesson on going a little deeper with negative exponents. But this is going to be our final video lesson. The extension can be done in class. So let's dive into 2.5 here. We're going to learn one more law and a couple variations of this law. So what do we got going on here? Again, same as before, I'm going to take this power of a power. So we have 4 to the 3, all in brackets, raised to another exponent of a 2. So this could be written as 4 to the 3 to the 2, which looks a little strange. So oftentimes what we'll do is actually just have brackets right here. Okay. And so when we have a power to a power, we can write that in repeated multiplication because all this is saying is take 4 to the 3 and multiply it by 4 to the 3 again, okay? Because squared means multiply it twice. So I'm going to write that first as 4 to the 3, okay, multiplied by 4 to the 3. And again, I have two of them because of this 2 right here. Well, I don't actually need to, I'm not going to do this big long step. And that's because review of last day, when we have same base, okay, and we're multiplying two powers with the same base, we just have to add the exponents. So we're using our product law, add exponents by what's called the product law we got from last day. This product law is called the product because product means multiplication. So we have same base being multiplied. So this is just going to be 4 to the 6. Okay, let's do a couple more and see the pattern. So again, we have 3 to the 2 to the 4. So this tells me I have 4 3 squareds being multiplied. Again, we can just add our exponents. I don't need to write this out as 3 times 3 times 3, 4 groups of pairs of 3s being multiplied, because I know I can just add these up. So 2 plus 2 plus 2 plus 2, 4 groups of 2 is 8. Finally, doesn't matter if I have a negative, we can handle this. So this is saying take 3 negative 5 squareds, or 3 negative 5 to the 2s. So I'm going to go uh, negative 5 to the 2, okay? And that's being multiplied by negative 5 all to the 2, and again, negative 5 to the 2. Try to make that clear that these are brackets. It almost looked like it was a 1 there, okay? But negative 5 to the 2 being 3 times. Well, again, we can skip right over and just add 2 plus 2 plus 2 to get, that's negative 5 to the 6. What rule can we create to reduce a power of a power? And it's actually, I find a little quicker, but all that we're doing here is, and I said it in a couple of these, but this is 2 groups of 3 fours. This is 4 groups of 2 threes. And when we say groups of things, or that is multiplication. That's the definition. 3 times 12 can be the same as 3 groups of 12 or 12 groups of 3 to get you 36. So all we're doing here is multiplying these. Okay, so we're just going 3 times 2 to get us 6. Here is 2 times 4, multiplying the exponents together to get 8, and 2 times 3, all the way over here to get 6. Okay, so our rule, we multiply. Exponents. When we're doing a power to a power. And now we'll get two extra versions here. So here's the first one. If I have something like a to the m to the n, I just multiply those exponents. So notice that that's multiplication in between there. But what if I have multiple things being multiplied, like an a times a b? Now, I just want you to remember that there is an exponent of 1 here on the a and another 1 on the b, and all we're doing is multiplying exponents together. M times 1 gives me a to the m, b to the m. Same thing here if it's a quotient. So it's kind of like the distributive law or feeding the chickens. I bring the n in, but the exponents must multiply with exponents. Remember that. Okay, so let's apply this new law called the power law or the power of a power law. Either way, and we see, okay, 6 to the 2 to the 7. We don't have to write this the hard way. It only wants it as a single power. I don't have to evaluate here. So we just need to multiply these numbers. So I'm going to get 6 to the 2 times 7, which is 14. That's it. We're done. Here, we're going to multiply our exponents again. So my base is -7. Put that in brackets. And 3 times 2, we're just multiplying, gets me to the 6. Careful here, we do have a negative sitting out in front. So I'm going to emphasize that negative is right there. And then I'm taking my 2 and I'm raising it to the 4 times 5 here. Okay, the 5 is not attached to the negative, which is going to be 2 to the 20. Okay, and this is perfectly fine. You could also write it as negative in front with 2 to the 20. I'd accept both answers. So we're going to take a look at this really quick in two different ways. So you always have BEDMAS to help you with these things if you want to, okay? But exponent laws can sometimes speed things up. So we're going to first do this question with exponent laws. And what that is saying is that I have a little 1 here and a little 1 here. So I'm going to be multiplying this in, okay? Basically squaring both of them. So that says -7 gets squared, and I'm multiplying that by 5 gets squared. And now that I've used this power law, I can actually multiply this out. So that's going to give me +49. -7 times -7 is 49, and 5 times 5 is 25. And then you'll want a calculator for this. Multiply those, and you get 1,225. Now, if we use order of operations, no big deal. We can see we'll get the exact same thing. So I'm going to rewrite the question, -7 times 5. Order of operations says do the brackets first. So that's going to give me -7 times 5 is -35. Square that. So when you square that, -35 times -35, you get the exact same answer, 1,225. All right, let's give this one a shot. So let's first use our exponent laws. So I can raise the 6 to the 4 and the -2 to the 4. Okay, all I'm doing is they have exponents of 1s and I'm multiplying those exponents. So this is going to give me 6 to the 4 on top and then -2 to the 4 on the bottom. Now we can't use any other laws here. These are not same base, so we're just going to evaluate both of these. 6 to the 4 is a pretty big number. It's 1,296. And we're dividing that by -2 to the 4, which is 16. And that actually, if you divide that now, works out perfectly to 81. And over here, I'll rewrite the question is 6 over -2 raised to the power of 4. So if I did BEDMAS this time, I need to do division inside here, which is going to give me -3. 6 divided by -2 is -3. And that final result, -3 times itself 4 times, is going to give me 81. We get the same answer, whether we use BEDMAS or exponent laws. Now, down here, with these questions, BEDMAS often will give us really huge numbers. It wasn't too bad above, but we want to simplify these first, and then we're going to evaluate. So do not use BEDMAS when we can use your laws. See, we have the same bases here, negative 2, and in all of these questions, we're working with the same base. So first here, I'm going to use my power law, and that's going to give me negative 2 to the 2 times 3, or negative 2 to the 6. Let's rewrite what we didn't touch. And now I see I can use my product law. We're just multiplying, so we have 6 negative 2's being multiplied times 3 more negative 2's, so we just add those up. So now I get negative 2 raised to the power of 9. Now that we have it simplified to a single power, we can evaluate and use your calculator for this. It's not that big, but you'll end up getting a negative because there's 9 negatives, 512. Next one here, we can do two different ways here. I could use my product law inside here, okay, and add exponents first, or I could multiply the exponent in. I could do the power law. Doesn't matter. I'm going to show you by, I think a lot of students lean towards simplifying brackets first, which I do actually recommend. So let's do that. We have the same base and two powers that are raised 1 to 2, 1 to 3. So our product law says add exponents. So I'm going to get 3 to the 2 plus 3, which is 5, and that's raised to the power of 2. Next, we will be multiplying our exponents using our power law. And so now we're going to see, what do I get? 3 to the 5 times 2, which is 10. Again, this is quite a large number. You'll end up getting 59,049. Now, I'm just going to switch colors. I'm going to go to green because I'm going to say, or I could have multiplied this in, okay, multiplying exponents, which would then give me, the brackets, sorry, would go away. So that would then give me 3 to the 2 times 2 is 4, times 3 to the 3 times 2 is 6. And then again, I would now add exponents this time second. So 4 plus 6 is 10, which is the exact same thing. All right. Two more and we are done this unit. Okay, brackets and brackets. Make these a little bigger to make it more, a little easier to read. Again, I'm going to start inside. So I'm dividing. So I'm going to subtract. We're going to use our quotient law. So this is going to give me negative 4 to the 4 minus 2, which is 2. And that's all being squared. Now I'm going to use my product law and multiply my exponents. So that's going to give me a new negative 4 to the 2 times 2 is 4. And now I'm ready to actually multiply this out. I've simplified it to a single power, and that will equal 256. Negative 4 times itself 4 times is positive 256. Finally, don't let this negative in front throw you off. It just means we're going to have a negative in front of our answer. Again, I'm going to do inside my brackets. I'm going to use my quotient law first here and subtract these. So that's going to give me 8 minus 6, which is 3 to the 2. Okay, so I'm just doing 8 subtract 6 here to get my 2. And then I still have this raised to the power of 2. So negative is still out front there. And now I have 3 to the 4. Negative again, still there. And 3 to the 4 is going to give me 81. So I get negative 81 overall. That concludes our final lesson. If I exclude the extension lesson for negative exponents. Recap, what did we learn? Well, whenever we have a power raised to another power or another exponent, all we got to do is multiply those exponents. Okay, that's all we're doing in all three of these blue lines. And then we did some examples to see how that can work, comparing it to BEDMAS. Maybe in sometimes BEDMAS might be faster. But again, if I went back to say, let's take a look at this one, 3 to the 8, 3 to the 6. These would be really big numbers, and it would make BEDMAS a lot more work. So using our laws, we can make it much more simple than evaluate. Okay, that's it, everybody. Have a wonderful time doing what you do. We will see you in class. Goodbye.